Question 6, we're told a curve passes through a point, 0, 3, and has an equation which is a function of x. We're told the derivative is 1 minus 2 by x minus 1 cubed. Find the equation of the curve. All right, so it's pretty standard. We integrate the derivative to find the equation. That introduces a c, a constant, and we use the point, the given information, to find out what the c is, and then we have the equation. So let's do that. Our function of x is going to be the integration of the derivative, which let's rewrite it slightly more nicely so that we can understand how to integrate it. With respect to x, okay, so it's a chain rule, and we just have to work out where things came from. So for the first one, the 1 sitting by itself, it came from an x. That's the easy part. All right, for the other one, we have x minus 1, and that would have come from a negative 2, because you add 1 when, you add 1 when you integrate, and you subtract 1 when you differentiate. So when we differentiate, that minus 2 would go to a minus 3. What also would happen is that negative 2, when we differentiate, would get put out the front. And we have a negative 2 out the front, so we're going to divide by this negative 2 to get rid of what would have happened. It cancels that negative 2 which is out the front. What also happens is what's in the brackets gets differentiated and put out the front, but that just produces a 1. And so we end up with something quite simple. And of course, we need the plus c because there is a constant at the end there. All right, we now know, or we know now, we knew from the start that when x is 0, y is 3. And so we want to put that point in and find out what c is. The point, 0, 3. So we know that 3 is equal to 0 plus 0 minus 1 is negative 1. And it is on the denominator because of the negative power, and we square negative 1, we get positive 1. And so it's going to be 1 over 1 plus c. c plus 2 is 3, and so that's pretty easy to work out. c is just 2. All right, therefore, we know the function of x is x plus, we'll write that a little more nicely, the way that it was given to us as a fraction with a positive power, and plus 2. And we're done. On to part B, and here we're told the tangent to the curve at the same point intersects the curve again at one other point, only one other point apparently. P, show that the x-coordinate of this other point satisfies this equation. All right, so to do this, we're going to need the equation of the tangent, and then we're going to find out where it intersects the curve. Right, so how do we find the equation of the tangent? Well, we have a point, we need the gradient. How do we find the gradient? Well, we have a function that tells us the gradient, and so we're actually going to use that and the derivative function. So we're finding the gradients at the point where x is 0, because that's the point 0, 3, is equal to 1 minus 2 divided by 0 minus 1 cubed. So we get negative 1 cubed, which is going to be negative 1. That turns the minus 2, well, 2 over 1 is just going to be 2 to start with, but it's going to be negative 2 because of the negative 1 on the bottom. And so we get 1, we end up with 1 plus 2 because there's minus a negative, and that turns into 3. All right, so it tells us the gradient is 3 and the point is 0, 3. 0, 3, we already know the y-intercept. All right, therefore, the tangent, because we know the gradient now is 3, and we know the y-intercept is also 3, the equation of the tangent is y is equal to 3x plus 3. Now we have the tangent, we want to find where it intersects the curve again. So we're going to solve the equation. What was the curve equation that we found before? And that was, of course, y is equal to x plus 1 over x minus 1 squared plus 2. So we want to solve these two equations, and the question is just asking us for the x-coordinate. And so we want to solve it and find x where these two equations intersect. Since y equals 1 and y equals the other, the easiest thing to do is to say one equation and it's really nice that it's the x values, is equal to the other equation. Let's put the x plus 2 together and then have the 1 over x minus 1 squared there. All right, we're trying to show that it equals what's up in front of us, up the top there. All right, so let's rearrange. Move everything to the other side away from the fraction, and we get 3x minus x becomes 2x, and we get 3 minus 2 becomes 1 plus 1, and that is equal to 1 over x minus 1 squared. Let's multiply both sides by x minus 1 squared, because that will bring it up to the top. Because it's multiplying by the whole side, we have to put it in brackets, x minus 1 squared, which is turning out to be rather nice. And that looks very close to what we're trying to get to. So just bring the 1 over, and we have shown that the x coordinate of P satisfies this equation. Right, into part C. Verify that when x is 3 on 2, it satisfies the equation, and hence find the y coordinate of P. Okay, so to verify that it satisfies the equation, we just have to put the x value in. So x is 3 on 2, and so what are we going to say? Let's put it into the equation. We get 2 times 3 on 2 plus 1 x, which is 3 on 2. Why would you write x? 3 on 2 minus 1 and squared minus 1 equals 0. Let's not say that it equals 0. We want to try and demonstrate that it equals 0, not initially claim that it equals 0. Okay, so we'll put equal sign on the next line. 2 times 3 on 2 just turns into 3, plus 1 turns into a 4. And 3 on 2 minus 1 is just a half, and a half squared is a quarter, and minus 1, which of course 4 times a quarter is 1, 1 minus 1 is 0, and so we have verified that it satisfies the equation. But because it is the x value, to find the y value, we put it back into the function, and we will find the y coordinate of P. They didn't give us a lot of space for this question. Right, so we're taking the 3 on 2, we're going to put it back into the function that we found. So of course that's going to make it x plus 1 over x minus 1. All right, let's work this out, make it a little easier. 3 on 2 minus 1 is just a half. So we have a half, and of course that was squared, and plus 2 on the end. Okay, so a half squared is a quarter, and 1 divided by a quarter is 4. 4 plus 2 is 6, and 6 plus 3 on 2, 6 is 12 on 2, and 12 plus 3, so we would get 15 on 2. All right, that tells me that the point P is 3 on 2 and 15 on 2. Done.